Alright guys, focus up front.
Okay, so today you guys are going to be learning about thermodynamics. So we want you now to answer the first question under the chart. Just answer as best you can what you know about heat. Well, heat is actually the transfer energy to another thing. So when you feel something that's hot, it's actually
giving off energy.
And that's what you're feeling.
And when you feel something cold, it's actually taking energy from it.
Yes.
So if you had an ice cube that you're holding in your hand, it's taking heat, your body heat, to change it from a solid to a liquid. That's why it always melts. And if you have hot chocolate and you leave it out in like cold or something and it gets really cold, its heat was escaping and going out into the cold. Does that make sense?
Alright.
You have a little clip. You guys hear this or no?
No, sir. There's no sound.
Is there a sound connector?
Yeah, you want to bring it back here?
Yeah.
Sorry about that. You got a very patient group here, so they can yeah, it's just like a minute.
Hey, so guys.
What's up, guys?
We're going to show you a Magic School Bus episode about
Or a little clip of it.
yeah, a little clip of it about and what you'll be seeing in the lab later today.
All right, ski goggles. Oh, not quite, Robbie. These aren't ski goggles. They're heat keepers. Heat keepers? What do they do? Whoa. Is it just for the next president, President? That's not hair, Ralphie. It's some kind of stuff.
is shown, it explains about the heat and where it goes when it's something hot into cold.
Okay. So we have a mini lab that we're going to do over here. So if you guys want to just come gather around. Gather here. So, just worked out, you'll be able to see the change in temperature. What we're going to do, and you can follow along on your lab sheets, so you guys should bring them with you in a pencil. We have different chemicals in here, not too close. You don't want to get them on you. But, and they're going to either turn on or cold when mixed with the water, and that's going to show you exothermic and endothermic reactions. And exothermic reactions are when the substance is being on heat, and that's what you feel is hot. And endothermic reactions are when the substance is taking in your body heat, and that's what you feel is cold. So,
As you guys can see on the board here, if you look at this, this is just plain old water right now. And if I dip this thermometer into it,
see the temperature over there?
here's the temperature in Celsius. The temperature right now is at 28 degrees Celsius. So we have a few different chemicals that we're going to mix in with regular tap water. And you can see if the temperature is going to increase or decrease. So let's pour in the first one, ammonia chloride. And we'll stir it up a little. And then when I put
So on the initial water temperature, you'll want to put 28 degrees Celsius for all of them. A control means that you're not doing anything to it, and that's just what you relate back to when you're doing the experiment.
And now, if we put it into, you guys can see that instead of it's 28.0 degrees Celsius, it got changed to 26.
So do you think that this reaction is losing heat or gaining heat?
Losing heat.
Yes. So that's an endothermic reaction. So the final water temperature is 26.2 degrees Celsius. And you can write whether you think it's an endothermic or an exothermic.
Exothermic.
means it. Yes.
Initial water temperature. You want to put in what the control is. So it's 20.0 Celsius. So that goes across.
Yeah.
The first column, the final water temperature was 26.2 degrees Celsius.
Now was this losing heat or gaining heat? The temperature was going down. It's losing heat, so that would be endothermic.
Okay. So the next chemical we have,
Calcium chloride.
so if we pour that into just regular water, stir it. Put in So if it's losing heat, is it going to be exothermic or endothermic?
So it's like 21.
Hold on. 21.2 degrees Celsius.
Let's see, does it feel cold? Oh yes, it does. And not too.
And if you look, so do we all have that written down? Alright.
Alright.
So the last chemical we have is lithium chloride. Yeah.
Now let's see, you have to do that for sure.
2 degrees. Okay. So you can see again, instead of the 28 degrees Celsius like the regular water, it's increasing to 33.3 degrees.
And that's well,
33.4 degrees Celsius. So if it was gaining heat and it was heating up, what do we think it was? Exo or endothermic? Exo. So everyone, let's get back to these things.
Are you turning the camera? Oh my god. Is that a phone?
Alright. So,
Alright, cool. So you guys can fill out the
But-
questions.
just while we're cleaning out these chemical Well, temperature is the measurement of kinetic energy in a system. And what kinetic energy is if I drop this paper and it's falling to the ground, that's its kinetic energy. So if I was to drop my computer on like my hand would hurt because of all the kinetic energy that fell to me. So temperature is just measuring the kinetic energy, while heat is the transfer of kinetic energy from one object to another.
Right. So in this experiment, was that heat or measured temperature, or were they related?
It was a measure of temperature.
And was it transferring temperature or was it transferring heat?
That's what I was transferring.
Yeah, very good. All right, number 2, what'd you guys get?
With a cup of hot chocolate,
Ashley.
endothermic or exothermic?
Or number 2? Yes, because it is giving off.
Well, I actually kind of put 2 answers. I said that a cup of hot chocolate would be endothermic if it's like left on the counter or something. But if it's like cooking, it would be exothermic because the water is being heat. But if it's like not cooking, then it would be endothermic because it's like the heat is like getting off the heat.
Right, so if you were to hold it while it was hot, it would be exothermic because it would be the heat would be coming through. Okay, number 4. Guys get. Matt.
And ice cube would be taped to the way.
Yeah, and any explanations? Okay.
It's because it is endothermic. It's taking in the heat to heat up. So ice cubes are solid, but they can turn into liquid. So when they're taking in the heat, they change from ice cubes to just water.
Okay. All right, does anyone have any questions?
Do you have a question? Anything about what we talked about our course this year? Nothing?
Yeah, Matt.
How do you get to choose what you want to do, or is it just
Oh, for the lab, we get to choose. Yeah, but it's based on what we've learned.
And do you get to choose if you want to do it or not, or is it like required?
There's a required project at the end of the year, and you have 4 choices: a dissection of a fetal pig or like a frog, teaching a lesson over multiple choices. We picked thermodynamics, writing a children's book, or designing an organism.
Did you guys enjoy the lab?
Was this useful, or was it just no?
Learn something?
You guys learned something new?
Yeah.
That's really cool, the thermometer connected to your computer there.
Yeah.
That's cool how that works. Excellent, excellent. You guys have any other questions for Jack or Danielle? Anything on the lab? Any questions on the lab? You guys have any advice for these guys as they move forward from 5th grade into their middle school years?
It was most fun. I actually enjoy it. Enjoying the clubs and sports and stuff like that.
Great advice, great advice. All right, let's give them a round of applause. Great job, guys. Actually, let's give them we'll give them the bottle rocket. Ready? Woo! Nice job, guys.